All right, false alarm. They're now going to be here for an hour. Could have made up just one part, but hey, it's not a bad thing to do two parts. All right, now we've got something here again called constant of proportionality. Now, really, we say this is our rate. Again, it's really like unit rate. Our rate is y over x. Okay? Remember how we would do like sugar and water? At the top, you see your y, you see your x. This time it's going to be the same thing every time. You're going to put the number on the y side over the number on the x side. Okay? Now, there's two charts. We got a horizontal chart. We got a vertical chart. Horizontal's left and right. Vertical's up and down. But no matter what, just like the alphabet, x will come before y. So we go over here. And hey, look. It always... Here, let's make a note here. It must always start at the origin. If you don't know what the origin is, it's at 0, 0. Okay? Now, if you guys need a little extra time, just pause real quick or go back and fix that. But down here, it starts at 0, 0. It's always going to start in this corner. If it does not, okay, then this is not a constant of proportionality here. Okay? So, your first number is 0 and 0. Okay? If we keep going, though, it ends up right there. Now, look, the number on the bottom is your x-axis. So if I go down, this is 4. And then my y-axis is 1. Because look, it says y up here. And then my next point is right here, which is 8 and 2. Okay. Now, there's no other numbers, so even though there's extra boxes there, it doesn't mean you have to use it. Okay. Now, the vertical chart's the same thing. I just put the numbers the same way. 4 and 1, 8 and 2. Personally, I like the vertical chart. So if you need to create your own, that's probably the easiest route. But just in case we see it the other way, the horizontal chart, it's the same thing. But always remember, when I put these numbers together, I'm going to put the y number on top of the x number. Okay? And really, what we do is you pick the set of numbers. Okay? Another thing, we don't, even though it needs to start at 0, 0, we don't want to use 0, 0. Okay? So this is good for us, but we don't want to use it. Okay? It has to start at 0, 0, but I don't want to put it into the fraction because some of you guys have already tried this. If I divide those two numbers, look what it gives me. We can't divide by 0 mathematically. So that's why we don't use it, but we need to start there. Okay? All right, cool. Well, here we go. Shoot, it's already done for us. Here's a horizontal chart. The table below has a proportional relationship. Remember, that means that all fractions are the same. So we only need to use 1. Okay? All right, cool. Well, we wanted to start at 0, 0, but again, those are the numbers that we don't want to use. So this started at 0, 0. Cool. Let's pick one pair. Okay? Now, what I would suggest you guys is picking the smallest pair. And the reason why I say that is because we're going to have to do the factor tree like we did in the last video. But sometimes it may be easier to use something like this because they're by tens. All that matters, well, really, it doesn't matter. You guys choose one that you feel most likely to break down the numbers in whatever way is easiest for you. Okay? Because they're all going to be the same thing. So, like here, hey, 8 and 20 is pretty easy, but so is 20 and 50 because that's just tens, right? 2 times 10, 5 times 10. But let's do 8 times 20. Let's do 8 and 20. Now remember, my rate is y over x. So my y number here is 20, and my x number here is 8. Sorry, that's ugly. Now before, what we would do is we would just divide these. 20 divided by 8 is 2.5 over 1. But with constant of proportionality, I cannot have a decimal. So we got to simplify this 20 over 8. Okay? Now, the only way to do that is let's do our factor tree. So let's do 20 first, if I break this down. Again, you guys have this to help you out. So 20 is 5 times 4. Okay? Or 10 times 2. It doesn't matter. I used the 20. Cool. Now, if you need to, go back and look at the prime numbers in the front. Remember, 5 is prime. I don't need to break that down anymore because I can't. 5 times 1 is the only way to get 5. But I can break down 2, and that's 2 times 2. And we know those are prime because that's what it says in the front. All right, well, the prime factors for 20 are 2 times 2 times 5. Now, again, I personally just like putting them in order from smallest to biggest. You can do biggest to smallest. You can put them in any way you want. But we got to do the same thing with the 8, okay? Go back to your chart and pick 2 numbers. Remember, we don't want to use 1, so do not choose 8 and 1. It's not what we want. Again, do not use 1. All right, well, 8, if you guys checked it out, should have been 4 times 2, right? Hey, I got a prime. I got one number there. Let's highlight or circle this so I don't get rid of it. I need that. And then 4 is 2 times 2. Okay, well, there's 3 2's there. So on the bottom, I got 3 2's. All right, now, when we get to this part, this is the easiest way for us to simplify. Now, some of you guys could simplify 20 over 8 and do it without the factoring, which is perfect. Okay, but just in case there's numbers that you can't see, this is the easiest way. From here, we are going to cross off numbers that are the same. Because look, if I divide 2 divided by 2, that's just 1. This really creates a 1, but anything times 1 is just itself. So I don't need that 1. Same thing here. These 2's are 1. It makes 1s. But I don't need that. It's almost like they cancel each other out. So, but don't think it gives you 0. It just gives you a 1. And let's say 5 times 1. Look at the number's just itself. Can I cross these 2 out? No, because they're not the same number. So, hey. 5 over 2. So look, 20 over 8 is 2.5. But there's a little circle right here on the left side next to the 20 over 8. If you push that little circle button right there, and you see how it turned white? Look at the fraction. That's the simplified fraction. So you push this, that button right there, and that's how you can check your work to make sure that it's the exact same answer that's right there. So our constant of proportionality is 5 over 2. That means if I were to go and divide all these numbers, so like, look, just to check my work, 30 divided by 12, because remember, it's y over x. 5 over 2. 50 divided by 20, 5 over 2. So that means for every 5 y's, there's 2 x's. Okay? That's what this stands for. So very similar to what we've done before, but instead of putting 2.5 over 1, we just want whole numbers as our answer. Okay? And remember, your rate is y over x. So we're going to be doing the same thing, back to back to back to back. Pick one set of numbers, one pair of numbers, put y over x, okay? And the constant of proportionality, our rate, is 5 over 2. So 5 y's to every 2 x's. All right, here we go. Remember, your rate is y over x. You're given a table that has a proportional relationship. Remember, choose one set of numbers when it says this. Find the constant of proportionality, so how many y's to every x's, in the simplest form. Remember, we want it to have 0, 0, but I can't use 0, 0. And that's okay. But I'm thinking that 50 and 30 are easiest ones. Let's say not of the fraction, or the negatives. We don't need to deal with that. 50 and 30 sounds about right. So r equals y over x. And on the y side is the 30. Which means that the 50 is on the bottom. Now again, do you guys need to break this stuff down? If you know how to simplify fractions? No. But just in case we don't, let's break down the 30 first, which I know is 3 times 10. And if you look back on the front, 3 is a prime number. I can't make that any smaller. But 10 we can. We go to our multiplication chart. Hey, look, there's 10. And that's 2 and 5. So 2 times 5. And then again, if we look on the front, these numbers are prime. All right, well, 2, 3, and 5. Those are the numbers that go up top over there. 2 times 3 times 5. Now we got to do the same thing for 50, okay? Which again, the reason why I chose this is because it's easy because they both multiply by 10. And you don't even have to go look at the chart. But now you know that 10, well actually before we do the 10, we know that 5 is prime. But when we break down the 10, we got 2 times 5. And again, if we just continue to go back and look at the front page, that's going to help us figure out which numbers I stop at. So we got a 2, we got a 5, and we got a 5. The numbers that match up, they make 1. So they kind of cancel each other out. We don't need them. A 1, and all that's left over is your answer. So in this case, it's 3 over 5. So again, for every 3 y's, I'm going to have 5 x's. And again, if you want to check your work just to be safe, push that little circle button and make sure you get the same thing. And we know that proportional means that no matter which of the 3 sets of numbers that we have, if you plug them in like that, you're going to get the same answer. Okay? So here's our last one, you guys. Remember, your rate is y over x, and you guys decide which numbers look the easiest. We love 0, 0. We love that it starts there. We just don't want to use it. But in this case, 8 and 18 is probably the easiest set. But it doesn't matter because whatever you choose, you're going to get the same answer. So 8 and 18, you guys cool with that? This one says apples are salt and apples. Okay? Shoot, it doesn't give me X and Y, but look, over here, it goes X, Y. Over here, it goes X, Y. Over here, it goes X, Y. So, down here, it goes X, Y. Okay? All right, well, hey, 18 is the second number, so 18 and then over, 8. So now our X and Y actually has some meaning, okay? We've got apples, which is Y, and salt, which is X. Same thing, though, as the last time, yeah? But hey, let's not worry about the wording right now. Let's just break these numbers down. So 18, let's break that down. Let's go to our chart if you need. Here's 18. And that's 6 and 3. 6 times 3. Cool. 6 times 3. But hey, on the front, 3 is prime, so I can't break that down anymore. But 6 is not. So that's 2 times 3. And again, if you need to use your chart, use your chart. But I went through that one pretty quick just because we should know what 2 times 3 is. All right, cool. Well, I got 2 prime numbers there. So 2 and 3 and 3. 2, 3, 3. Now we got to do 8. We should know what 8 is, but again, if we don't, come over here. That's 4 and 2, yeah? So 4 times 2. I know 2 is prime. 4 is not, so I got to make that smaller. And you'll start to notice that all of the numbers are going to, you're going to know when to stop because all the prime numbers you're going to see are there's not very many of them that you can use. So we got a 2, a 2, and a 2. 2, a 2, and a 2. All right, well, hey, this crosses out, gives me a 1. But can I cross those 3s and 2s out? No. All right, well, let's put those together. That says 3 times 3. What's 3 times 3? And then on the bottom, I have a 2 and a 2. So 2 times 2 is... All right, well, 9 over 4. Is that correct? Push that circle. I mean, yeah, look at that is. And then again, if you tried all the other ones, they're going to give you the same thing. So what this is telling us is our rate is 9 over 4, and it's y over x. So that means 9 cups of apples for every 4 ounces of salt. But the only thing is we don't want to use the decimal when it comes to constant of proportionality. Unit rate we do, but this one's just a little different. Okay? So with that said, you guys, there's your work down here. Okay? And we're good. If you guys need any help or any questions, feel free to send a classroom announcement or a remind. Okay? See you guys.